All right, for single replacement reactions, we have an element and a compound before the arrow, and they're not a hydrocarbon and oxygen. For these ones, we have to check the activity series. So if you look on your notes page, the bottom half of the first page is the activity series. That tells us how reactive the elements are. So we're doing metals, which means that the metal will come in and replace the first element from the compound if it's more reactive. So we did reactivity in the periodic table unit. The most reactive elements tend to be from the left side and the bottom of the periodic table, but there's some exceptions to the rules. So we do this list to tell you which one is the most reactive. So the most reactive element on the activity series is the one on the top. So if you're looking at the notes, that's lithium. So lithium, potassium, calcium, sodium, magnesium. Those elements, when we think of those, we think of things that aren't metal. Like potassium, we think about bananas. Calcium is milk. Sodium is salt. Those are all compounds. So the more reactive ones end up in the compound. The less reactive gets kicked out as a single element. So the ones at the bottom, gold, platinum, silver, copper, even lead and tin, we think of those as metals, so they tend to not usually form compounds. So the reaction only happens if the element by itself is more reactive, higher on the list than the metal in the compound. Now, hydrogen is not a metal, but it's on our list. That's why it's blue. Hydrogen will act like a metal when it's in an acid. So our first reactant, hydrochloric acid, HCl, hydrogen is going to act as the metal there, and it'll leave as H2. So the first thing we have to do for all of our reactions is check whether the reaction can happen. So let's check all of these. And I'm going to tell you now one of them is not going to react, and we're going to put no reaction. We don't even have to worry about the rules. So the first one, we have zinc and hydrogen. That's what we're comparing. So if zinc is higher than hydrogen, the reaction happens. And if we look at our list, zinc is higher than hydrogen. So that reaction is a go. That one is yes. I'll come back to that one. Now, looking at our next reaction, our single element is Cu, even though I really made it ugly. That's getting compared to Fe, which is iron. So we're comparing copper and iron. And we can see copper is lower on the list than iron. So this reaction can't happen. The most reactive one is already in the compound. So for the right of the arrow, for this one, we say no reaction. You can abbreviate it no RXN or write out reaction. I'm going to do the abbreviation. Our last one, we have iron versus silver. So iron is higher on the list than silver. This one will also go. Now for this last one, it's telling you the charge. This activity series also tells you which charge it will be. So a lot of these are transition or heavy metals. Whatever charge it has on the right of the arrow in that activity series, that's the charge that that metal will take, if it can change. Okay, so let's look at our reactions. So we said the first and the third will happen. If it does, we're gonna kick out the first element. The element coming in pairs up with the anion. So we have, it doesn't matter if we do the element first or the compound. I'll do the compound first. Zn pairs up with Cl. We should crisscross the charges. Zinc is always +2. And chlorine is always -1, so that's going to be ZnCl2. And again, that's because this was +2 and this is -1. And then hydrogen gets kicked out as just H. Well, not quite. If you're looking at the activity series, you'll see that hydrogen is listed as H2. Hydrogen is one of our 7 diatomic elements. So that's our formulas. I'm also going to add the state symbols. So with these reactions, we can assume all of the compounds are aqueous, and hydrogen's the only one that's a gas. All the other metals are going to be solids, unless I give you mercury. Okay, balancing this one, 2H, 2Cl on this side, only one there. We just need a 2 in front of that reaction. Okay, so those are the 2 example ones. Try to do the one for you to try, and I'll put that up in 1 second. So we said this one will react. Iron is going to pair up with nitrate. This is telling you that it's going to be the +2 version. Nitrate's -1, so that will be a 2. And silver gets kicked out as Ag, and that will be a solid. We need a 2 here and a 2 there to balance it. So that's single replacement. So single replacement, check the activity series, make sure that the single element is higher on the list than the one in the compound, kick out the element if it is, recross the charges, and then balance it. So that's it for that type.